everyone, welcome back. I'm Domingos. I'm also known as DMA, and I appreciate when I'm called DMA. Today we have this powerful integral to solve. But if you're watching this video, that won't be difficult for you anymore. We have integral of square root of x squared plus x plus 2 plus square root of 4x squared plus 4x plus 4 over square root of x to the power 4 plus x cubed plus x squared. And we have a condition given that x is a positive number, or in other words, x is a number greater than 0. Okay, so what is the approach that we're going to be applying in this problem? First of all, what we have to check in this problem is that inside this square root, the square root inside the other square root, we have 4. That means 4 is a common factor. So we can factorize 4. Okay. And here, in the denominator, we have x to the power 4, x cubed, and x squared, meaning that we can also factorize x squared. Okay, so if we can, then what is going to happen? We're going to have square root of x squared plus x plus 2. I can say this 2 is 1 plus 1. So I'm going to have x squared plus x plus 1. And where does the other one goes? We will show you where it goes. If we factorize 4 here, that means we're going to have square root of 4 that will come out as 2. So that means going to have plus 2 square root of x squared plus x plus 1. Because this is, if enters with the index 2 and enters 4, and 4 multiplying all the in expression goes back here. So the one that I said, these two can be written 1 plus 1, I can put 1 here. So putting 1 there, I can call this as 1 squared. Why 1 squared? Because this expression inside the square root is the same as the outer expression. So even if I put square root of and put all to the power 2, it cancels back. So we can say this is the principal square root. So we can say this is square root, and we can say to the power 2. It cancels over. If I factorize x squared here, I'm going to have x squared over x times x squared plus x plus 1. That's what we're going to have here. And now, if we look at this expression, this is similar to a squared plus 2ab plus b squared, because I have my a squared plus 2ab, so this is 2 times this expression times 1 plus b squared, which we know it's equal to a plus b all squared. Okay, perfect. So if we apply it there, we're going to have integral of square root of x squared, which is my a, plus 1 all squared. And in our denominator, we have square root of x squared times this expression. We can separate them, each one with the square root. So if we say square root of x squared, some would say it's absolute value of x because x is a variable. Okay, you're right. But remember, they already stated that x is a positive number. So we know that square root of a positive number will always be a positive number. So that means this square root of x squared can be x. So we're going to have over x square root of x squared plus x plus 1. Okay, dx. That's perfect. We can cancel these 2 with the index, canceling it out because the index is 2 and the exponent is also 2. So what are we going to have? We're going to have integral of square root of x squared plus x plus 1 over x square root of x squared plus x plus 1 all dx. Okay, so that's the expression that we're going to get. So that means we reduced all this expression into this expression. Now, what could be the next approach? We can separate each one with the denominator. So this is the common denominator, and we have addition in our numerator. So we can take this one with the denominator and this one with also the denominator. Okay, doing that, we're going to realize that we have square root of x squared plus x plus 1 over, we're going to have x times square root of x squared plus x plus 1 which is dx, plus integral of dx over x that multiplies x squared plus x plus 1. Okay, for the first integral, they can simplify. So if they can simplify, we can get dx over x, because this simplifies, so it becomes dx over x, which is a known integral, which is ln of x, or ln of absolute value of x. But since they already stated that x is greater than 0, there is no need to include absolute value, but it's okay. And we have this part here to solve. Okay, this is integral 1. I'm going to call this integral 1, and I'm going to call this integral 2. So this is integral 1. Integral 1 is equal to this expression, which is equal to ln x. Okay, perfect. Ln x. Now for the integral 2, we have x times square root of x squared. When we have inside of a square root a quadratic function, and outside we have a polynomial, particularly first degree polynomial, so we can let whenever we have this type of integral, we can let 1 over x to be equal to t. We can let that 1 over x to be equal to t whenever the integral is similar to this integral. So if we let 1 over x to be equal to t, what we can do, we can now isolate x and try to find the derivative of x, and the derivative on the left side and the derivative on the right side. If we isolate x, this implies that x is going to be 1 over t. The derivative of x is 1, so I put dx to state that I was differentiating with respect to x. And the derivative of 1 over t is minus 1 over t squared and dt. Okay, and dt. Obviously, if x is a positive number, 1 over x will still be positive, so that means t inevitably is a positive number. Okay, so if we substitute back here in our integral 2, we're going to have integral, where there is dx, it's minus 1 t squared dt, over, where there is x outside, we can put 1 over t, times, where there is x, we're going to have 1 over t squared plus 1 over t plus 1. Okay, equal. And now we're going to have, if we find the common denominator inside and we take it out, because the common denominator is t squared, and we can separate the squares, so the denominator t squared can come out as just t. Of course, it will be 1 over t because it's in the denominator. So we're going to have minus 1 over t squared dt, and here we're going to have 1t times, here will be square root of, since it's common denominator, then that means will be 1 plus t squared, because this is 1 over t squared. But if you check, the square root of t squared can come out, become just t, so I can put the square root here and just t here. So if I have t times t will be t squared. So 1 over t squared is the same that it is in the numerator. So we can cancel them out. So we can cancel them out, we can cancel them out, we can cancel them out, and it becomes just like this, the negative. This is what happens. This becomes just like this. This negative can come out. The negative can come out, so we have negative integral dt over square root of t squared plus t plus 1. So our integral is reduced to this expression. But now this integral is quite similar to this one, but the difference is there is no polynomial expression outside multiplying. It's just 1. It's a constant 1. So what we do, we try to transform this quadratic polynomial into a quadratic form, in a perfect quadratic form. So which is the formula that we stated before here, this formula here, a squared plus 2ab plus b squared, for us to try and transform this one into this way. We already have t squared, which is a squared, but we don't have the 2, but we have the a, because it's again a here. We don't have b, because we have to have 2a to know what is b. But it's not a problem. We can say this expression can be written t squared plus, I don't have 2, so I can include the 2, But not to alter my problem, I have to multiply by 1 over 2t. Because 2 cancel, then goes back to t. It will be missing b squared. Then my 1 over 2 becomes my b. So b squared definitely is 1 over 4. But not to change, I have to take this 1 over 4 plus 1. This one comes from here. They cancel out, goes back there. So this part here can now be applied, this expression can now be t plus 1 over 2 squared. And if we do a quick calculation here, we're going to have, this is going to be minus 3, in this case. If we find the common denominator, this is 4 here, this is 4. So this is going to be plus 3, in this case plus 3, because it's 4 minus 1, so 3 over 4. Perfect. Okay, perfect. Okay, so when we get here now, we can just go further and try substitute this expression into here and see what is going to be the solution for this given problem. Okay, perfect. Let's then solve it. Okay, now if we check here, what is going to happen? We're going to have this is equal as negative integral dt over square root of t plus 1 over 2 squared plus, I can put square root of 3 over 2 all squared. There is no problem. This is a standard integral, which is equal. This is a standard integral, which is equal to ln. So this is going to be negative ln of. This is now my t. This is now my t. So this is going to be t plus 1 over 2 and plus square root of. Now what is going to happen? So we're now going to have my t squared, which is this expression, t plus 1 squared. This is positive, then that becomes positive a. Right. Okay, perfect. Which is square root of 3 over 2. Okay. Squared. This is the standard form. Okay, fascinating. Perfect. Okay. Now, we were not given our problem in which respects to 2, so we have to substitute back. So this is going to be, we have to substitute minus ln. What is the value of t? The value of t is 1 over x. So this is going to be 1 over x plus 1 over 2 plus square root of 1 over x plus 1 over 2 squared plus, this can be square root of 3 over 2 all squared. Okay, all squared plus c. This is going to be the solution for our problem. Okay. Now if we check, this is the solution for integral 2. Now the final solution has to be integral 1 plus integral 2. So that means the final solution, the final solution will be integral 1, which is ln x, minus ln of this expression, 1 over x plus 1 over 2 plus square root of 1 over x plus 1 over 2 squared plus, this can just be 3 over 4. It's not a problem. Plus c. I can call just c1 or plus c. So we can apply the ln property, ln of a minus ln of b. It's not a problem. So we know that ln of a minus ln of b, it's equal to ln of a over b. If they subtracting, they divide arguments. If they adding, they multiply the arguments. So the final solution, let's just use imply here. So therefore, the final solution will be ln of x over 1 over x plus 1 over 2 plus square root of 1 over x plus 1 over 2 squared plus 3 over 4 plus c. So this one is the solution for that given integral. This is how we should solve them, and that's it. That's done. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.